Naming ionic compounds with polyatomic ions. Okay, now before we start talking about naming ionic compounds with polyatomic ions, let's just remind ourselves of how to name both cations and anions, and then also how to put it together to name ionic compounds. Now, for a cation, it's actually pretty simple. You're going to use the name of the element, and then you're going to add the word ion. So, for instance, here we have sodium plus, so that's the sodium ion, or the sodium cation. And sodium is just the name of the element, and we've just add the word ion, or else if we want to be a little more specific, we could add the word cation, and that's completely fine. With calcium ion, it's very similar. So we have calcium 2 plus. Calcium is the name of the element, and then we're just going to add the word ion. Now, with some elements, and they are found in the transition metals part of the periodic table, or the D block, we have an opportunity to have more than one charge on that cation. So for instance, iron can be iron 2 plus, or it can be iron 3 plus. So we have to specify which one we're dealing with in the name. So for instance, iron 2 plus would be iron, and then parentheses, Roman numeral 2 to indicate 2 plus ion. Notice we don't have a sign in there. We don't need that. We just need iron, parentheses, Roman numeral 2, and ion. And that tells us that we're dealing with the iron 2 plus cation. The iron 3 plus cation is exactly the same way, except for now we've just indicated that 3 plus charge in parentheses by using Roman numeral 3 inside the parentheses. So with elements that can have more than one characteristic charge, we do have to indicate that using Roman numerals and parentheses as part of that cation name. For anions, it's actually both a little easier and a little harder. So the easier part is that we don't have to worry about variable charge. The harder part is that we actually do have to change the name from the elemental name to an ion name. So let me just use an example. Here we have the chloride ion. So how did we get here? Basically, we took chlorine, okay, that's the atom, and we hacked off the ene, so we used the stem, which is chlor, hacked off ene, and we added IDE to that. And now we have the chloride ion. Or we could call it the chloride anion, which is just a little more specific, but it's totally fine. Same thing with nitride. So we have nitrogen as the element, and we take the nitra part of it. So nitra, I don't know how to exactly say that, but you get the idea. So there's the stem, and we remove the ogen. So get rid of the ogen part, and we're going to add IDE. So now we have nitride ion. So again, practice those and get those into your head, because sometimes, as you can see, you take off a little more of the stem than you might think, like with nitrogen. We want to make sure that we use only the NITR part, and then add the IDE for the nitride ion. Now, when we name ionic compounds, it's actually really simple. So first we name the cation, then we name the anion, and then we put the two of them together, and we leave off those words ion for each one of those. We don't need numerical prefixes if there's more than one ion necessary to balance the charges. Basically, we can get that because we know that those charges have to balance, so we don't need to tell people how many of each ion that there is. So, for instance, sodium chloride is simply just sodium chloride. Sodium is the name of the cation, chloride is the name of the anion. We put it together and we have sodium chloride. Same thing goes with magnesium oxide. So magnesium, 1 magnesium 2 plus cation, 1 oxygen 2 minus anion. Put those two guys together and we end up with magnesium oxide. Now, magnesium chloride, this illustrates a different part of this. And so what I was trying to explain is that here we have our magnesium cation. We require 2 chloride anions to balance out that charge. So this is the correct formula. So we have 2 chloride anions, 1 magnesium cation, but we still just call it magnesium chloride. We just put the two names together. We do not call it magnesium dichloride. That would be incorrect. We don't need to tell people that they need 2 of them because they already know that, because they know they have to balance the charges. So saying magnesium dichloride would actually be very redundant. Now, what happens if we have cations that have more than one possible charge? Well, when we're naming the compound, we just have to keep that Roman numerals in parentheses part of the name of the cation. So as long as you include that, you're actually made in the shade. So for instance, iron sulfide, and this one's also called iron sulfide, if we didn't have the name, if we didn't have the charge in parentheses here, we actually wouldn't know which of these two iron sulfides it is. So this is correctly said iron 2 sulfide. So that tells us that this is iron 2 plus. Each sulfide anion is 2 minus. Balance out the charges, and we have one iron cation, one sulfide anion, and there's iron sulfide. Now, it's also possible to have iron 3 plus, which we just saw. So here's iron 3, and sulfide is still 2 minus. So we need 3 of those to get a total of 6 minus, 2 iron 3 plus cations to get a total of 6 plus. Offset those charges, and now we have iron 3 sulfide. And notice on both of these that no numerical prefixes appear in the name. We don't need them because we know that we have to balance those positive and negative charges. So that's a very, very key part of both constructing ionic formulas and naming ionic compounds. Okay, so this video was about polyatomics, so let's get to that right now. Now, there are some ions that the majority of it, or the ion itself, is all covalently bonded, which we haven't talked about that yet, but we will. So, like ammonium, the nitrogen is covalently bonded to the 4 hydrogens. But the structure overall has a +1 charge. You could say the same thing for all of the rest of them. Okay, so they're covalently bonded, but the overall species has a charge. Now notice most of these polyatomic ions are negatively charged. And so that's one thing that makes it a little bit easy to remember. But having said that, you do need to memorize each and every one of these polyatomic ions, both the formula and the charge. So you have to be able to recognize them. You also want to memorize the name. So name, formula, charge for each one of these polyatomic ions. That'll help you name compounds. It will help you in doing reactions, because polyatomic ions are going to be transferred as a group. So in a double displacement for reaction, for instance, they would be swapped, but they would stay together. So an important part of this is that, say, let's look at bicarbonate anion here. That polyatomic ion does not break apart, so it's going to travel basically together. So let's look at a few compounds that contain polyatomic ions and get a clearer picture of what we're talking about. All right, when we name an ionic compound with a polyatomic ion, basically it's exactly the same as naming compounds that don't include polyatomics. So we're going to use the same rules, but instead of using the, instead of having to derive the name of the anion in most cases, we're going to have to just simply use the name of that polyatomic. So that's why I mentioned you need to memorize the name so that you have that in your head. So for instance, let's look at this compound right here. Now, if I didn't have my polyatomic ions memorized and I didn't recognize this big, huge piece, Cr2O7, if I didn't recognize that as a polyatomic, I might be very confused. And so basically I would be thinking, wow, there's sodium, that's a metal. And there's chromium, that's another metal. And now there's 7 oxygens, and I don't know what to do with this. But if you memorize your polyatomics, then you'll recognize this as the dichromate ion. Has a charge of 2 minus, and so it requires 2 sodium plus 1 cations to neutralize that charge. And then we're just going to call it sodium dichromate. Name of the polyatomic, name of the metal cation. Same thing goes for calcium hydroxide. So each hydroxide is -1. Calcium forms a 2 plus cation. We put the 2 together in the name, just calcium hydroxide. Name of the cation, name of the anion. We need 2 hydroxides to balance out that charge, so we put parentheses around that polyatomic and put the subscript 2. just like we did with single atom compounds. So if we had calcium chloride, for instance, we have Cl and then we'd have 2. Well, we just have hydroxide in there instead. And then also remember with calcium chloride, we're not going to have parentheses because we just have calcium and then we have chloride to subscript 2 because that's the anion, or the anion. Okay, so let's look at the last one, potassium phosphate. So again, here is your anion. It's 3 minus. You have that memorized. And because you have that memorized, you then know that you need 3 potassium cations in order to offset that charge. So we're going to have potassium subscript 3 of them for 1 phosphate anion. The name of the compound is going to be potassium phosphate. Now again, you're not going to use numerical prefixes in the name if there's more than 1 polyatomic ion. So that goes for compounds that don't include polyatomics as well. The only exception, though, is if you have a polyatomic ion that already includes one. So for instance, up here we have sodium dichromate. There's one of those prefixes, but that's okay because it's part of the name of the polyatomic ion. Same with triiodide. So if you go back and look at that chart, you'll see triiodide there. And that prefix should be kept as well because it's the name of the polyatomic ion. Now, if you need more than 1 polyatomic ion to balance the overall charge in the ionic compounds formula, then you're going to take that polyatomic ion and you're going to put it in parentheses. And you're going to write the numerical subscript outside the parentheses. So let's look at an example with calcium nitrate. So we're going to have calcium ions, so that's calcium 2+, and nitrate ions, so that's NO3-. So we have 1 minus here, 2 plus here. So we know that we need 2 nitrate anions to balance out the charge of our calcium 2+ cation. So to write the formula properly, we're going to have to say calcium, and there's just one of those. We're going to have to put nitrate in parentheses, so the entire thing in parentheses, and subscript 2, telling us that there's 2 of them. Now notice I didn't include any ionic charges in the compound, so that's just the same as before. So I would not write NO3- as part of this. That would be incorrect. Just nitrate 2 balancing out the charge with calcium 2+ cation. Now, here are two other ways to write this that are both incorrect, but you can kind of see the logic. So for instance, let's say that you decided you wanted to keep all of the nitrogens together and all of the oxygens together. So 3 oxygens in nitrate, 2 of them, that would give you 6 oxygens and 2 nitrogens. And so let's say you separate them. Well, that would be totally incorrect. It's not even close to the correct ionic formula. It obscures that you have the polyatomic nitrate in there. The other one is actually also wrong because it's very easy to misinterpret. So this looks like it has 32 oxygens in the compound. And of course we know it doesn't. And so that's why we need our parentheses around that nitrate anion, and then the subscript 2 telling us that there's 2 of those as opposed to 32 oxygens in the compound. Okay, so let's look at the example that includes our polyatomic cation, which is ammonium. So we have ammonium, those are NH4+, so +1 ions, and we're going to bond those with sulfide anions, so that's sulfur 2-, sulfide 2-. So we're going to write that. We need 2 of these and 1 of these guys. So we're going to write the ammonium in parentheses. We need 2 of them, so we're going to write a subscript 2 outside the parentheses and then sulfide. Okay? So, and again, the name is just going to be ammonium sulfide without any prefixes. We don't call it diammonium sulfide, for instance. It's just ammonium sulfide. We know the charges need to balance, so that's what tells us how many of those ammonium cations that we need. So just be sure to use parentheses where required. You only use them with polyatomic ions. You don't use them with monatomic cations or monatomic anions, as we saw previously. Okay, so let's just summarize what we've done. To name an ionic compound, basically we're just going to take the name of the cation and the name of the ion, we're going to put them together, and we're going to remove the word ion from both of those. Now, the rules for naming ionic compounds that contain polyatomics are exactly the same as for naming other ionic compounds. So the only difference is that you have to recognize that you're dealing with a polyatomic ion. That's why you need to memorize the name, the formula, and the charge. Now, if you need more than one polyatomic ion to balance the overall charge in the ionic compound's formula, then be sure to use parentheses. So put the parentheses around the polyatomic ion and then put a subscript saying how many of those there are. And remember, that subscript goes outside the parentheses. Now, this is a very challenging topic, and so be sure to practice, because seriously, you get so much better with practice.